I prepared a summary on A4 of how to calculate confidence intervals for proportions, which you use for categorical variables, and for point estimates, which you use for continuous variables. And I've uploaded that to Learn. This video just shows how to do the calculations in Excel and also how to use the confidence interval calculator, which is a little Excel gizmo that I've uploaded to Learn. You'll see that on the right hand side of my screen I've got the data set in Excel of ESS5SL that's got about 8 or 9 variables in it. And on the left hand side I've got a little reminder of the formula for calculating the standard error of a proportion and the standard error of a mean or other point estimate that you use in calculating confidence intervals. And below that I've got the confidence interval calculator, and I'll just briefly show you how to use that as well. So let's start with the variable trust PLC in the second column of the data set. The first thing we can do is calculate the mean for that variable in the sample, and that comes out at 6.24 to 2 decimal places. Now, that's the estimate for the mean that we have in the sample. To construct a confidence interval, we want to know what the value in the population is likely to be, and we do that by taking effectively 2 standard errors above and below the point estimate, which gives us a 95% confidence interval. And the reason it's a 95% confidence interval is that we're within 2 standard deviations of the middle of the sampling distribution, and that's where 95% of the random samples we would draw if we just drew sample after sample after sample instead of taking only one sample would lie. Yeah. If you're unsure about that point, have a look at the revision PowerPoint on the binomial and inference, or look at some of the videos produced by Chris Wild that are in the resources section of the Learn site. Here I'm just concentrating on how to do the calculations, but it is important that you understand what you're doing when you do the calculations and what the logic behind them is. So the sample estimate for the mean for this variable, trust in the police, is 6.24. We want to know what the standard error is. So our relevant formula is the standard error of the mean, and that's, we want to know the sample standard deviation for the variable, and then we divide that by the square root of the sample size. So to get the standard deviation for this variable, I've done this already, I just use the formula in Excel, standard deviation, open brackets, the numbers that I want to include in the calculation of the standard deviation, which is just the values of trust PLC that are in rows 2 to 1601 of the data set, the 1600 cases, and let Excel calculate it, and it comes out at about 2.374. I then need to divide that by the square root of the sample size. The sample size is 1600. The square root of 1600 is 40. If you want to check how to calculate that, just do equals square root, open brackets, the number we want the square root of, which is just the sample size, close brackets, enter, 40. Yep. So we want to take this figure here and divide it by 40, and that will produce that figure there, 0.059, or as near as damn it, 0.06. Yeah? We then want to multiply that by 1.96, because remember we want just under 2 standard errors above and below the point estimate to give our 95% confidence interval. So that's just 1.96 times the number we just calculated. That gives us that number there. And then all we have to do is take our 1.96 numbers away from 1.96 standard errors away from our sample mean, and 1.96 standard errors added on to our sample mean. That's the first calculation, that minus that. Let's just do the second one. That would be equal to the sample mean plus, let's put it in brackets, 1.96 times, and our standard error was there. There we go. There's an easier way I could have done that, which is just to take equals sample mean plus, plus we've already calculated what 1.96 times our standard error was there. Get the same result. That's how to calculate the 95% confidence interval for a point estimate, or the mean of a continuous variable. Let's look at how to do it for a proportion. The only extra complication in calculating a proportion is we need to find out what the proportion is. We need to get Excel to calculate that for us. So let's calculate the proportion of the sample who are in paid work. The variable MNACTIC describes the economic activity of the people that were interviewed in the survey, and one of the categories is paid work. Let's find out what proportion those people are in the sample, and then produce a 95% confidence interval of our estimate of what the proportion is likely to be in the population, in the adult population of the UK. I'm just going to do a quick pivot table to get the proportion. So click on data, click on pivot table, drag the variable name down to values, and there I get a nice little frequency table of the variable MNACTIC. And you'll see that there's 784 people who are reported as doing paid work out of a total of 1,600. So let's just do a quick calculation. Equals 784 divided by 1,600, 0.49 to 2 decimal places. It's 0.49000. Otherwise, well, let's just check what Excel is doing here. Let's increase the number of decimal places just to make sure that. Yeah, no, it is 0.4900. That's bang on. Let's go back to our sheet. The data is. Right, our population, beg your pardon, our sample proportion is 0.49. Our standard error from our formula for the standard error will be, first of all, let's calculate the proportion times 1 minus the proportion. That will be 0.49 times, well, 1 minus 0.49 is 0.51. Which comes out at 0.2499, or virtually 0.25. We need to divide that by n. which as before is 1600, which gives us that figure there, and then we need to take the square root of that figure. Oops. I'll put an equal sign instead of a parenthesis there. We get that figure there. So our standard error of the proportion for this variable is 0.0125. We then want 1.96 times that standard error. Which comes out at about 0.0245, and we just add that and subtract that from our sample proportion to get the 95% confidence interval for the population proportion. So the lower bound will be 0.49 minus that, which come. Hang on, I've used the wrong sign in there, which comes out at 0.466, and then 0.49 plus 1.96 standard errors, which is 0.5145. more or less. And the range between these two values is our 95% confidence interval for the population proportion of people who are in paid work in the target population, which is the adult population of Great Britain in the year the ESS 5 was fielded, which was from memory 2012. We could also have done these calculations using the standard error and confidence interval calculator. So let's just put in 1600 for the sample size. The sample estimate of a point estimate there was 6.2375. The sample standard deviation was 2.3737. And there is our 95% confidence interval. Let's just compare it with the figures we got here. Very slightly different, due, I presume, to rounding, but the differences aren't important. And there's our 99% confidence interval. Let's try it with a sample proportion. Let's go with 0.49 for the proportion of people in the sample who are in paid work. 0.49. Whoops. I see what I've done wrong with the other one. Let me just go back to the example of the standard error of the mean, the sample estimate. I put in 2.737. I missed out a 3 there, and that's why the numbers came out slightly differently. Now you'll see that the numbers are exactly the same as on the original Excel spreadsheet. Let's go on to the sample proportion. Sample size is the same. Sample proportion is 0.49. 9. The standard error of the proportion it calculates as 0.0125, which is the same as we got here once it's been rounded. And you'll see that the 95% confidence intervals are the same as we calculated over here. The nice thing about the confidence interval calculator is it gives you 99% confidence intervals as well. Saves you having to do the calculations in Excel, but either way is perfectly acceptable. To use the confidence interval calculator for a new set of numbers, you just replace the numbers. And when it doesn't have the numbers it needs, you'll see little warning signs in the appropriate cells. So that's confidence intervals. If you find them tricky, the best way to understand confidence intervals is just to calculate some of them. And if you found quiz 7 difficult, the best solution to that is just to calculate the confidence intervals 95% for each of the variables in that data set. The calculation shouldn't take you long. By the time you've done them all, you'll have a very firm grasp of what confidence intervals are and what they do. That's it.